Hello, my name is Richard Hastings and I'm a member of Tarmac's National Technical Team. During this session, we'll be running through the compelling reasons why warm temperatured asphalt should be the default for manufacturers, servicing contractors and clients. I'll be joined later by Niall Barrett, an operations manager with Tarmac Contracting, who will describe the on-site benefits and efficiencies that can be achieved with warm mix asphalt. The question we are posing today is why wouldn't you? So firstly, let's look back at the UK's journey with warm mixed asphalt. In 2010, Tarmac, along with the Carbon Trust, Transport Road Research Laboratory and others embarked on a major project aimed at developing the market for low temperatured asphalt in the UK. This was then followed by the Transport Road Research Laboratory project that involved laboratory, production and laying trials, which successfully demonstrated that it is possible to achieve similar in situ performance with low temperatured asphalts to those experienced with conventional hot mixes. The TRL project report 666 was published in September 2013. Within that report, there was a graph that categorized the different types of mixes by temperature. Cold mix, firstly, is a very different type of asphalt manufactured at ambient temperatures. And examples of that would be emulsion or foam-based asphalts. These are commonly used for recycling base and binder layers on contracts. Half form is asphalt manufactured below 100 degrees. This was introduced but did not gain momentum within the UK. Warm mix is typically manufactured 40 degrees less than the equivalent hot versions. And this is what we'd recognise as warm mix asphalts in the UK today. This asphalt follows the model that is in use in North America and mainland Europe as well. The performance of warm mix is no different to standard hot mixed asphalt. The asphalt has the same binder penetration grades and is manufactured with the same binder contents as hot mix. The asphalt has the same design parameters and in situ voids criteria. So apart from all the sustainable and efficiency savings, there is no difference between hot mix asphalts and warm mix. All standard asphalts are available in warm mix, with the exception of hot rolled asphalt surface course, where pre-coated chippings are to be applied. The temperature of the asphalt would not provide sufficient heat that would enable the successful embedment and adhesion of the pre-coated chipping. Back in 2019, sustainability was all over the headlines. Extinction rebellion marches, pupils striking, nice one kids, and the UK declared its climate emergency. 74% of district, county, unitary, metropolitan authorities, plus 8 combined authorities and city regions signed up for the declaration. So in total, 310 authorities and regions have signed up. And the next steps is to develop effective action plan to achieve carbon reduction. Can we help? Certainly. We are some of the low-hanging fruit. The use of warm mix asphalt saves up to 15% carbon, and there are many other examples of asphalts that are more sustainable. In 2019, political direction and specifications supported warm mix asphalt. The all-party parliamentary group for highways was published, Working Better for Roads, in September 19. And it included these quotes: "Carbon reduction lies at the heart of the government's construction strategy as it works to achieve its emissions reduction targets and move UK to a low carbon economy. Warm mix asphalt now accounts for significant volumes worldwide, almost 40% of production in the USA and over 15% in France, but remains underutilised in the UK, where it represents less than 4% of asphalt production. UK authorities need to get on board and support an industry that is focused on reducing carbon footprint. It is time to catch up and make warm mix asphalt the norm in the UK." The introduction of the Highway Works in July 2019 includes warm mix asphalts within it for base, binder, surface course, SMAs and thin surface systems. We talk about carbon reduction, but what does a ton of carbon look like? Well, image on the left shows a 10mm sphere, which is a representation of what is the volume of a ton of carbon. The image on the right shows New York with this CO2 represented in spheres produced in 1 hour. You can just about see the Empire State Building roughly at the same height, some 381 meters. Now imagine that carbon mounting 3 times bigger. That would equate to 61,000 tons carbon, and that is the saving that the All-Party Parliamentary Group said would be achieved if the UK switched to warm mix asphalt annually. Can we confirm the carbon savings? Yes, through carbon calculations. Reports can be provided on specific schemes, or in the example shown here, for a local authority to demonstrate the total carbon saving of switching its annual supply from hot mix asphalts to warm mix. The data is also handy for evidencing work within the declaration action plans of carbon saved on assay schemes or contracts. So what about Tarmac's journey? We introduced warm mix asphalt under our overarching banner of Ultilo in 2013. Since its introduction, we have supplied in the region of 3 million tonnes onto the strategic and local road networks and off-highway schemes. We've encouraged the use of it by strategically switching plants to majority warm mix. One of our largest plants, Mount Sorrel in Leicestershire, is now running at 85% total asphalt mixed being warm mix. However, this is the exception. We have led the campaign forward for warm mix asphalt, and it now accounts to close to 10% of our total sales. Although this is higher than the 4% stated at the time by the All-Party Parliamentary Group, there's still a huge amount of work for us to do to increase that percentage. So far, we have highlighted the carbon saving related to warm mix asphalt, but as you can see, there are many more benefits associated with it. I'm now joined by Niall Barrett, who is the operations manager for Tarmac Contracting, and we would like to discuss the other benefits that can be realised to the contractor, the client and the public through the use of warm mix asphalt. Niall, perhaps if you could tell us a bit about your role within Tarmac to start with.
Yeah, thank you, Richard. My name's Niall Barnett. I work for Tarmac Contracting, based for the East Midlands. Worked for the business for about 12, 13 years now. Progressed from a contracts manager up to operations manager. So currently I look after, as I said, East Midlands, where we have a core of 6 gangs, and that sort of flexes up given the needs of the business. Obviously we undertake works surfacing from Highways England works to local authority to sort of PIC market, whether it be smaller car parks and the like.
Thank you for that. Now, what I'd like to discuss is the benefits that are derived from warm mix on site. So if I could ask you a few questions, Niall. Firstly, please could you explain how productivity within a shift could be improved with the use of warm mix?
Yeah, certainly. Obviously, your productivity on site is key, and really looking at the work within a shift, where basically by using a warm material, we effectively can gain an extra 2 hours because of the cooling of the material. So whereas we could say a material is cooled sufficiently after an hour, with it being warm, if it was hot mixed, it could be 3 hours. So effectively, that extra 2 hours can give us the potential to increase productivity, but also it gives us surety of what we're going to complete within the shift, but also the opportunity to possibly open up the traffic as well sooner if the needs be.
Okay, thank you for that. And as this with this saving, has that reduced programs?
Yes. When you look at reduced programs, obviously that's something that everybody wants to see and strive for. As an example, on the M1, a recent scheme that we've done, obviously working for Highways England, where you have working windows, where it's quite a tight constraint. So, if you have a working window of a 10-hour slot, it might be that if you were using a hot material, you wouldn't be able to actually achieve what you need to achieve for the designed output each night, without having to actually go to working, say, at weekends. So you would have the opportunity to extend the working window. So, for instance, if you were working on a project like that, you could have 6 shifts that were available to you in a week. Whereas if you were using a hot material, it might be that you weren't actually able to complete the outputs required on a Monday to a Friday. So that would put you into just working possibly just on a Saturday night. So effectively, you would just achieve 1 shift's worth of productivity in a week as opposed to 6.
Okay, and wasn't there an instance on this site where it was obviously planned to be laying wall mix, but for unforeseen circumstances, some hot mix had to be laid on the site?
On that particular scheme, unfortunately, one of the shifts we had, there was an issue with the production plant, where hot material had to be supplied for, I believe it was the final few loads, which meant that we knew ahead of opening the carriageway back up that it would rut. So it was a case of being able to open the carriageway to traffic the following day to lay the material, but with the full knowledge and agreement that the material would fail during that day, and it would have to come out the following night. So it was quite a good example of where to use, or where the benefits of wall mix on site particularly are shown and proved. A case of proof of the pudding, really.
Yeah, and I guess totally endorsed, the work that you do with Highways England in the scheme being designed around wall mix asphalt, and showed very clearly what would happen with a wall mix laid in a similar circumstance.
Yeah, definitely.
Okay, thank you for that. And with wall mix, you get a reduced cooling time. Has this benefited sites where you've been able to open it to traffic earlier?
And it's sort of, obviously the reduced cooling time brings an element of surety of the programme, so that you've got that extra time where you will achieve what you need to achieve each shift. But sort of moving away from possibly some of the Highways England stuff, schemes like that, working sort of with local authorities where you might be on restricted hours. For instance, you're outside of school or something similar, where you had this window where you had to open back up by the sort of 3 o'clock in the afternoon. Using a wall material would give you the opportunity to know you've got that potential extra 2 hours, but also if you were monitoring the temperatures, once you got to the required temperature, then you would be able to indeed open up to traffic earlier, which means that you would meet the criteria of working under restricted hours, but also not inconvenience any of the travelling public for any longer than was necessary.
Yeah. I can see the importance of that with the disruption that would cause to traffic, or indeed with the school that you mentioned there. I guess there's other efficiencies that can be gained with wall mix as well.
Yeah, looking at it sort of more from the operative's point of view and the actual site workings, there's obviously, if we are there for a shorter amount of time, it enables road markings, traffic management, all of those other sort of the peripheral operations that are involved within the surfacing, to be on site for less time, to be able to complete their works, not to have potentially additional shifts after the surfacing was completed to complete their works, for instance, say for road markings.
I see, yeah. So it's another benefit of wall mix. And whilst we talk about benefits, I suppose we cannot forget the safety aspects on site. the benefits that are derived there?
Yeah, obviously, you know, warm mix is a lower temperature to start with. So once we start compacting the material, there will be sort of less steam evidence when we're compacting. We've obviously got lower emissions through the whole of the operation. And also it generally just improves the general working environment from using a warm material.
Great. Okay, that's a really great insight into how warm mix, in addition to the carbon benefits we associate with material, derives or delivers, I should say, benefits to the site as well. Niall, thank you very much for joining this discussion. Very much appreciated. Thank you.
Yeah. Thank you, Richard.
The question I posed at the beginning of the session is, why wouldn't you? There are compelling environmental, efficiency and safety reasons for warm mix asphalts. Therefore, I encourage you to think, why would I use hot mix? Thank you for joining this session, and if you have any questions, we welcome them through our live chat. Thank you.